Good afternoon and welcome to the webinar Data Management Process for Smart Factory Success. This event, brought to you by Quality, is sponsored by Mitutoyo. I'm your moderator, Daryl Sealand, Editorial Director of Quality. Thanks for joining us. Today's presenter is Jeremy Banks. Jeremy is a data management specialist with Mitutoyo America Corporation. With time spent in the field as an end user, and then with Mitutoyo providing application support, Jeremy has more than 20 years of experience in the metrology field. With a background in coordinate metrology dating into the 1990s, he has seen the inspection industry grow and shift with customer demands that triggered leaps in technology. Don't forget to submit your questions, and later in the program, our presenter will address as many as possible. Today's event is being recorded and archived on qualitymag.com. And now I'm excited to turn it over to today's presenter, Jeremy Banks.
Hello, my name is Jeremy Banks. Today we're going to talk about data management systems. Primarily, we're going to talk about selecting the right partner to design your data management system. So let's go ahead and begin. As manufacturing companies move towards implementing modern techniques such as industrial Internet of Things and statistical process control, many companies find integrating measurement data collection into their network can be difficult. Many questions arise, such as what technology is available, which products are better for an application, and which supplier can be trusted as a partner to guarantee success. This presentation details how to select the right partner, hardware, and software needed to fit unique applications. Whether it's a single inspection station or multiple facility installation, find the products and solutions to bring it all together. When choosing your partner, the first issue is some companies only produce gauges, connection hardware, or software. How can companies know products from 3 different suppliers will work together? The solution, identify a single provider of metrology hardware, software, and services. A manufacturer with a diverse product line can provide the required gauges, connection hardware, and data collection and management software needed, all made and supported by the same vendor. Another issue, implementing electronic data collection plant-wide seems costly, and low-quality gauges are not an option. How can a company meet its goal without exceeding budget? The solution, many companies already own and use high-quality gauges equipped with SPC output. By adding accessory data management hardware, these gauges are ready for use in your new system, which reduces the cost of having to purchase replacement gauges. Another issue, your company produces a diverse product line. You need a solution that is flexible enough to meet your current needs and your future needs as well. The solution, data management products need to be modular and independent from the tools, allowing for use on different gauges as needed. The same data management hardware can be repurposed for future applications. Also invest in software options that are scalable, allowing users to increase usage easily as required. We're going to discuss the smart factory concept. Below is a diagram illustrating a common initial implementation of a smart factory concept. The core of the implementation is the customer's network. All manufacturing equipment is directed by a system that supports techniques such as CAD/CAM program generation, pallet shuttles and robot integration, and automatic offset feedback. Process monitoring is managed through the network, resulting in visualization of uptime, machine usage, and health, as well as better preventative maintenance scheduling. Measurement data is managed by data collection and SPC software. All inspection data is collected by real-time software and stored on the customer's network in a database. This data can be collected from hand tools connected to a PC by wired or wireless data collection systems, PC-controlled systems such as vision or coordinate measuring machines, or even machine tools equipped with in-machine probing. As you can see from the diagram, the blue is the field network. Equipment is controlled through the customer's network. Process networking is yellow. Process monitoring of machine tools and smart measuring systems is also supported on your network. And for the measurement results, the measurement data is collected and stored in a database which is conveniently located on the same network. Understanding the goals of a smart factory. In regard to the measurement results, a smart factory concept improves work efficiency, allows the management of the measured data to be integrated within the network, and enables easy deployment. So we're going to talk about those one by one. Number 1, improve work efficiency. A smart factory implementation should improve work efficiency by including electronic data collection. The goal should be eliminate errors in data, reduce wasted time during inspection process, and increase the ease of use to the operators. All of these benefits will improve work efficiency. Number 2 is integrated management of data. Management of measured data should be integrated into the customer's network. This requires digitalization. By having all of the data on the network, reporting and analysis is able to be performed more efficiently. This will also facilitate efforts to implement paperless initiatives. And third, it should be easily deployed. The most important attribute of a smart factory implementation is that it should be easily deployed. The implementation should be well supported by your partners. It should be affordable in initial purchase and cost of ownership. It should be flexible enough to grow with your business. This is the factory view. We're going to visualize what a factory-wide system looks like. A smart factory is more than just having a few inspection stations or a well-equipped quality lab. A smart factory is plant-wide. Audits, inspections at the point of manufacture, quality control and assurance checks, as well as final inspection should all be collected and managed by the same system. Using a company's network, all of the measurement data is centralized, increasing efficiency of analysis and reporting. A very important topic when you're discussing smart factory implementation is electronic data collection. Conventional data recording requires the operator to measure the sample, review the data, and record the data manually. This record is usually transferred to a spreadsheet or some other software by keyboard entry. This can result in errors in data collection, as well as a time-consuming and troublesome process. By collecting the measurement directly from the gauge, the process is faster and easier with less errors. Some of your common issues. Manual input of measurement data is inefficient and frequently generates mistakes in entering data, such as transposing numbers, missing decimals, etc. By using electronic data collection, the electronic data collection immediately transmits the measurement data to your PC. Errors due to manual input can be eliminated, improving data reliability and operational efficiency. Another issue, implementing an electronic data collection solution can be costly, requiring capital investment in many replacement gauges. Data management hardware uses existing SPC connections, whether wired or wireless is desired. Existing gauges can be retained and fitted with accessory cables, resulting in a lower implementation cost. Wired connections, while reducing measurement error, may feel unwieldy, resulting in difficulty of use. A wireless system can be used in addition to or instead of wireless solutions. The ability to be used in combination with a cable allows flexibility in the design and use of your data collection system. Wireless data transmission is thought to be unreliable in a noisy industrial environment. Not all wireless technologies are the same. Select one proven to maintain a strong signal connection and that's been tested in poor conditions to replicate typical manufacturing spaces. We're going to discuss some data management hardware features. Not all companies provide these features, but we're going to talk about them nonetheless. Dustproof and water-resistant IP67 models use only data management hardware designed to match or exceed the gauge's IP rating, so that dust and coolant protection features of the gauge are preserved. Many gauges contain a data button on the tool, but for those that don't, connectors are usually available that contain the button instead. This allows the user to easily trigger the data. Compatible with Excel spreadsheets. Most data management solutions can provide an interface that is HID compatible so that it thinks it's a keyboard. This allows simple data entry directly into any software, even spreadsheets. A high wireless range. Range is connection reliability. By using a wireless technology with superior range, users can be assured that the transmitters will perform in even poor conditions. Select a wireless system based on the Zigbee specification over Bluetooth or BLE. This allows for long-range, high gauge count applications while providing long life and low maintenance costs. And data management as an accessory. As accessories, all of the data management hardware, including wireless, should be able to be moved to another gauge while routine calibration or repair is required. This again reduces cost and time spent pairing devices. Data management solutions can be divided into three categories: wired, wireless, and software solutions. Wired solutions such as USB direct cables or SBC cables combined with USB converters or multiplexers, as well as data loggers and printers. Wireless solutions are transmitters that connect with a flexible cable or transmitters that connect with a rigid connector. Of course, these will go back to a wireless receiver or dongle. And then software solutions. There are Excel-based data collection solutions and then data collection real-time SPC type software. Wired solutions are inexpensive, reliable, and easy to set up. Traditional styles use an SPC cable to connect the gauge to an interface that then connects to the PC. Modern styles connect the gauge directly to the PC by USB. Each style has important features and benefits. Wireless solutions allow data to be transferred without being tethered to a PC. This allows gauges to be taken to the part rather than the part being taken to the inspection station. This is extremely useful when workpieces are large and heavy or inspectors want to measure parts while still within the manufacturing process. Two styles that are very convenient are the rigid style. This allows a very rigid connection to the gauge. It's usually form-fitting, easier to use. The connection cable style is more versatile. It also allows to be connected to a greater variety of tools. Regardless of which type you use, they all go back to a wireless receiver or dongle, and then that's connected to the PC. Software solutions help inspectors manage their data. Excel-based applications are very common. They provide users with tools to dictate where the data is recorded in spreadsheets and manage which gauge data is collected from. Real-time statistical process control software does the same thing while also performing live statistical process control and database retention. Now we're going to run through an example of data management hardware selection. So below is an example of how gauging data management hardware and software is selected. First, we're going to start with the gauge. Start with selecting the appropriate gauge. In this example, we're using an indicator. Now, this indicator, of course, has SPC output. Now we're going to select the hardware that will connect to your gauge. For the indicator, an SPC cable will be used. We just need to make sure that we select the right shaped connector for this indicator. Now we're going to select our interface. Select the interface to the PC. A USB converter will connect the SPC cable and then the USB port on the PC. So basically, this allows us to connect our gauge with an SPC cable. The SPC cable goes into the interface. And now we select our software. Select your desired software, and SPC software will collect the data from the gauge and apply real-time statistical control as the operator measures the sample. So generally speaking, you usually have four components. You're going to have the gauge, the connector, the interface, and then the software. Here's an example in use. In this application, the operator is using an indicator mounted in a stand to measure the sample for height. The measured results are captured whenever the data button on the gauge, cable, or USB converter is pressed. Alternatively, a foot switch could be used to capture data. The data is then collected by the SPC software. Pre-control charts and histograms are used to ensure the process is in control. Real-time data tests such as linear trend and out of tolerance can be monitored as each part is captured. Each complete subgroup allows calculation of CPK or PPK, which allows the operator to ensure customer requirements are being met as parts are produced. Data management software is used to tie everything together. All of the data measured throughout the facility should be collected by one software and then managed from a centralized database. Connectivity to the database by other software such as MES or ERP allows data to be used without duplication. It is important not to overlook the value of data management software. It is the last but most important component in a data management system, and in many cases will determine how successful an implementation will be. So the next steps. Now that the smart factory concept, the benefits of electronic data collection, and the features of a data management product line have been reviewed, the next steps in an implementation of a data management system should be discussed. So first, select your metrology partner. Ensure you are working with a partner who can provide not only the metrology equipment, data management hardware, and software that you need to meet your goals, but also the services that are required, such as training, technical support, repair, and calibration. Select your gauging and metrology equipment. Start with selecting the appropriate gauges. Ensure each gauge has an electronic output option, whether SPC output, serial, USB, or text file output. The gauge needs to be able to share its results. Remember that data is only as good as the tool, and inferior gauges will only result in inferior data. Select your data management hardware. Wired or wireless connections can be used in any combination as required. Consider the measurement process and the environment when selecting the connectors, and interfaces needed to get measurement data into the PC. As an accessory, data management hardware can be added to existing gauges that have SPC output ports. And finally, select your data management software. Software not only collects and stores the data, but is the primary reference an operator uses when measuring samples. Software should guide the operator through the inspection process and ultimately make it easier for them to do their job. Consider not just interfacing hand tools, but also instruments such as profile projectors, profilometers, and CMMs. So I know we went through that very quickly. Once again, thank you for your attention during the presentation. Your time is valuable to us. I'd like to open it up to some questions. So Daryl, please go ahead.
Thank you very much, Jeremy. Yep. As we promised, we're going to take some time and see if we can go through and answer some questions that have come in throughout the presentation. So let me start, Jeremy, with question. First question is, I see that the presentation stresses working with a partner to develop the total system. Does this mean I can only use equipment from one manufacturer?
Okay, so equipment can be used from multiple manufacturers as needed. However, standardizing has benefits. So by using the same brand tools, you're able to ensure each tool has similar output capabilities and will be able to communicate with the rest of your system. So while it's possible that you could use tools from different vendors, just make sure that you're selecting tools that have appropriate capabilities or equivalent capabilities.
Okay. Next question is, I like what I see, but I'm concerned that implementing something like this will be daunting. Does everything have to be done at once, or can I implement things over a longer period?
Okay, that's a good question. So implementation of a data management system can be done at once or in stages. So the stages that a customer chooses are determined by their individual needs. Typically, companies implement by department or they implement by technology. So by department means that they pick an area and set up any digital gauges, data management hardware, and software completely before moving on to the next area. So if I have 10 cells, I'll start with one cell, set it up completely, make sure everything's working before I move on to the next. That's typical. Another way is by setting up by technology. So by technology means that they implement digital SPC gauges throughout the entire facility before they move on to the data management hardware, and then they move on to the software. So they're doing it in a piecemeal style. Some people find this is better suited for their budgeting. Other people think that by rolling out digital gauges, they'll get more time to train their operators on how to use those gauges, and then they can move on to the cables, and then they can move on to the software. So either one of those methods is good, either by department, where you do it all at once in one department, or by technology, where you do each one step at a time.
Okay. Brittany would like to know, how would a company that is required to operate under GMP conditions go about validating data management software?
Okay, so when you talk about software validation, there's usually three components, and of course most of my history is more lean towards the FDA, but when you're doing FDA validation or aerospace validation, you have to validate the actual installation, When using data management software, you're going to need to get the installation procedure from the manufacturer, and then of course follow this, and that'll ensure that the software is properly installed, because software doesn't work if it's not properly installed. So that's usually that's usually the first requirement of validation, is getting the instruction and properly installing it. The second requirement is proving that the software is going to do what you want. This is, of course, this is where your salesman, can do a really good job of convincing you of that. But there's a actual document that can provide the information. So most manufacturers will be able to provide a document that lists all of the functions of the software. So then you can use that document to ensure that the functions you need are available. So that's usually the second piece, is making sure the software is going to do what you want. And the third component of validation is proving that the software, when properly installed in your system, it is actually performing as you want it to. So that's the third step. Now this one's harder to justify, because you can't just get a letter from the manufacturer and say everything's good. You actually have to test it. So what most people do is, after they properly install it using the first document from the supplier, then they'll use the second document that tells them all the functions, and they'll go through the functions that apply to them and test the expected behavior, and then just verify that it behaved as expected. So those are the three steps: proper installation, ensuring the software is going to do what you want, and then proving the software, once installed, is performing properly. So I hope that answers your question, Brittany.
I'd also like to encourage anyone in the audience who does have a question for Jeremy to go ahead and get your questions into the Q&A chat box. Our next question, Jeremy, comes from Alan, who'd like to know what wireless technology, i.e. RFID or Bluetooth, do you recommend for asset tracking of gauging and metrology equipment?
So for the actual tracking of the equipment or collecting the data, so those would be two different things. Generally speaking, you could use RFID, although most manufacturers aren't going to provide that. Most manufacturers, if anything, they'll provide a QR code on the device that you could scan with a barcode gun and track. But if you had the ability to attach RFID to the gauge, that would be a good wireless technology to use. I don't know that I would use Bluetooth, because Bluetooth requires more battery, where RFID is passive. So I'd stay away from Bluetooth as far as tracking the gauges. Now, if you're talking about sending data, well, then there's a couple different technologies out there. Of course, I'm biased. Working for Mitutoyo, we encourage Zigbee. Zigbee's good because you can use a high gauge count, 100 gauges per receiver. You can have 15 receivers, so you can have a gauge system with 1,500 gauges. The transmission range is large. It's 60 feet. Of course, the greater range that you have, then when you're in a poor condition and you reduce the range, you'll still have sufficient range and connectivity. Now, of course, you can use Bluetooth. Bluetooth isn't bad. It just doesn't support as many gauges. It doesn't have as much range. So if you're in an environment where you're going to use few gauges and you're only going to use one at a time, something like that, then Bluetooth is a good option. Zigbee is better in an industrial environment. Also, some of our competitors use a signal called ANT+. It's very similar to Zigbee, so that's not a bad option either. But Zigbee does have better battery life and greater usage. So if you're looking for something passive to keep track of the gauges, RFID is a great idea. QR code would be a good way to do it with a barcode gun. But data transmission, I would rate probably Zigbee, ANT+, and then Bluetooth. So I hope that answers your question.
Sure. Okay, our next question is about automated data transfer from gauge to software. And the question is, can the data be transferred to a web-based software, or does it only work for installed software versus web-based software?
So it depends on the device that's sending the data. In automated situations, we're usually talking about computer-controlled equipment. Or it could be a serial device. And serial devices, there's less options. It usually just sends the data out, an RS-232 port, and your options are pretty limited in that. You usually just go to another computer. Now, if it's computer controlled, normally the output will be in the form of a text file. And then this text file can be saved to a network location. So with the Mitutoyo software, with the Measurelink software, we can monitor a networked folder. So as the data is being collected by the automated device, it can store the data to a network folder. Then we would periodically check that folder and then import the data. And then, of course, we'd send it up to the database, which is on the network. Now, I think in the future, we're going to be moving towards more IP style connections. So instead of sending a text file, we're going to stream data to like OPC UA or MT Connect. So what this would do, this would allow data to be sent to an IP address. It would be streamed. It would be stored in that IP address, and then it could be accessed by other systems. Some software already support this type of data collection. We do with our MeasureLink software with MT Connect. Other software only support the text file, which is usually adequate. But going forward, I think we're going to be moving closer to this IP, UP or OPC UA, MT Connect style data transfer.
Okay. Next question is from John. He wants to know if you have any tips for making the transition from spreadsheets where data is siloed based on station or function to a relational database platform where custom reports can be generated.
Right. So a lot of people, when they first start collecting data, they use a spreadsheet. Most of them have a spreadsheet for other applications. They're familiar with this. They're comfortable. So they immediately, they'll create a data sheet and just start dumping data into that. But what you find quickly is that the data is then just stored in spreadsheets. It's very difficult to access. It's very difficult to combine with previous data or historical data to generate reports. So that's a big step. And to go from a spreadsheet into a relational database. Of course, the easiest way to do that is to purchase a data management or data collection software. So the data collection software will basically enable you to connect your gauges, measure your parts. It'll guide the operator through the inspection, almost like a work instruction. And while it's doing this, it's collecting all the data into the relational database. So as soon as the pieces are measured, it's in the database. The engineers monitoring this database can then generate reports as the pieces are being measured. So you could have a dashboard showing you live performance, or you could wait until everything's done and then generate your reports. So going from a spreadsheet into a relational database is a big, important step. And that's one of the core pieces of a data management system, is having everything centralized. So my tip would be buy the appropriate software. A lot of people try to either write their own software or use a piece of their ERP. Maybe there's a module for their ERP software. But I'd recommend buying a professional, real-time statistical process control software like MeasureLink or something comparable.
And that kind of leads right into our next question from Thomas, who basically just asks, are there any specific data collection or analysis software programs that you would recommend?
Well, I'm biased. I work for Mitutoyo. Mitutoyo makes a great software, the MeasureLink software. But there are several out there on the market. And I'm not going to name any names, but you know, a little Googling will do you some good. What I would stay away from is there are some softwares that are built as plugins to Excel. And although that sounds very convenient, they're extremely limited in their scope, because at the end of the day, the data is going to be in a spreadsheet. So I would recommend looking at a software that the back end is a relational database. There's several of them out there. Just make sure that when you look, a primary concern, of course, are the functions I need there. But second to that is cost of ownership. Most software, whether it's CAD software or quality software, are going to have an annual maintenance fee or something like that to make sure you get your tech support. So as you're looking at this different software, don't just look at the initial cost, also look at the cost over time, and you'll find that some are more affordable than others over time. So of course, if you wanted a demonstration of our software, we can follow up with anybody interested.
Okay. Now, Alan would like to know, does Mitutoyo support time series databases?
Time series databases instead of relational databases. So primarily, So primarily, we support relational databases. The MT Connect function does time-based. So as you send the data is time-stamped, and it will be basically stored in the pipeline. And you could use that type of function, but most of the MeasureLink software, most of your SPC softwares are going to use relational databases. But if you But if he had a specific question as how that would relate to our software, he can reach out to us and we can answer that with one of the tech support guys.
Okay. John actually has a follow-up and asks about any online web interfaces for data management platforms that you might recommend. Basically a cloud platform that provides a dashboard and allows for generation of custom reports.
Okay, so our once again, I'm going to recommend our measuring software. We can use the Azure, the Microsoft SQL Azure system to do cloud-based storage, and then of course we can use our software to display a dashboard using our process manager. Now, of course, that's what I would recommend. But many manufacturers make similar applications. Some of them make pure web browser-based dashboards that you could use. So while I would recommend the Mitutoyo software, if you're looking for something that's pure browser-based, there should be an option out there for you to grasp.
Okay. Ken would like to know how he would set up a demo, specifically on electronic data collection.
Well, of course, you can reach out to any of our staff. I believe that we're going to have some contact information go out, and also that last page of my presentation has had a contact. But the best way to do is to contact either myself or one of our local representatives or distributors, and then we would set up when we do a meeting. Generally what happens is we'll come in and look at your facility, of course, and see what you're doing and have you tell us what you're trying to get to so that we can understand your goals. And then we'll show you the appropriate equipment, show you our options, do a demonstration of the software and how everything ties together. It's more than just can my gauge send data, it's what do you want to do with the data at the end. So we'd like to have a good understanding of what each customer wants because everybody's needs are different, and then we can show them what they specifically need to see. So as far as setting that up, just reach out with the contact information that's provided in the webinar, and then we can support that.
Okay. Looks like we have one last question so far. Okay. Says, I noticed the presentation that the data management hardware components described are all accessories. What about integrated systems like calipers with built-in wireless?
Okay, so yes, in the presentation I primarily discussed accessory systems, and I stressed several times that accessories are preferred because they have many advantages. But a lot of our competitors or a lot of people make integrated systems. So they'll have a caliper with built-in Bluetooth, or they'll have a caliper with built-in ANT+. So accessory systems are superior to integrated systems in functionality and cost of ownership. So if you buy a caliper that has built-in wireless, that's easier to purchase because it's just one part number. But at the end of the day, when you're trying to use this gauge, all gauges need calibrated. So when you take that gauge out of service to be calibrated, you have to remap the transmitter because the transmitter is part of the gauge. The identification of the transmitter chip will change every time you have to do a calibration, and that requires more time, and of course time is money, having to remap those. So if you use an accessory instead, then you would just swap the transmitter to the replacement gauge. The transmitter doesn't change, you don't have to remap anything, the process is actually much faster, and of course time is money and that saves you time. Also with built-in, let's say you buy a caliper, a 6-inch caliper, and then you find as you do a changeover you need to move to a 12-inch caliper. Well, now you have to buy a 12-inch caliper that also has built-in Bluetooth. So that gauge is going to cost more money than a standard gauge without it. If you have an accessory system, you would just take the transmitter off the 6-inch and put it on the 12-inch and you're off and running. So one thing to keep in mind is as you're looking at these integrated gauges, it depends what really you're looking for. If you just want to transmit the data, an accessory system is going to save you time and money, and time is money. So I'd recommend sticking with accessory. So of course, if anybody has any other questions about that, I can help you out.
Excellent.
Okay.
Actually, it does look like we have one question that just came in. Brittany, once again, she'd like to know what is the typical ROI on implementing data management software?
Okay, so that's a hard one to calculate, and it would be based on your pain points now. But some things you're going to see on ROI are, of course, going to be time savings, right? So as you think about it, as an operator measures parts, he has to pick up the part, pick up the gauge, measure the part, then set down the gauge to pick up a pencil and write down the numbers or type in the data. So by going with a data management system that utilizes electronic data collection, just pressing the data button is going to save you time, the time necessary that you're spending now recording the data. Also, it would eliminate errors. So your data is not only going to be faster, but it's going to be more accurate. And of course, anytime you make a mistake, you have to go back and check. So that's going to be a time saving as well. Most data management systems also help you save money with SPC. So using statistical process control, you're able to reduce your scrap or make adjustments before you make suspect parts. So this reduces how much inspection you need to do, which saves you time and money. It also reduces your scrap, which of course, scrap is money. So any of those would be helpful. But the hidden one that most people find is by doing a data management system, they get away from paper. And printing paper, generating paper reports is time consuming, but also the cost of paper is expensive. So by all of those affecting, faster, less time spent doing inspection, reducing scrap, reducing suspect parts and sorting, and then reducing your paper usage are all good items for a return on investment. So I don't have a specific number for you. It kind of depends on how much inspection you're doing, how much paper you're using, how much scrap you're making to see what that return is.
Right. Okay, excellent. That is all of the questions that we have for today. So please join me in thanking Jeremy Banks for his presentation, as well as our sponsor, Mitutoyo. If you have any additional questions or comments, please don't hesitate to click the Email Us button on the console. Please also visit webinars.qualitymag.com for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you found this webinar to be a valuable experience. Have a great day.